చేసిన చూసినావా? Hello guys, welcome to one more session of this high-speed hydrology course. So retrospecting what we studied earlier. So in the last class we discussed about how to work out mean precipitation. Okay, so because of we could not cover frequency analysis in the last class because we solved so many questions on mean precipitation because it is very, very important, especially the Thyssen-Palgen method is very, very important. So we covered decent number of examples related to Thyssen-Palgen method. Now the one more important topic related to precipitation is frequency analysis of rainfall data. Okay, before we go into the course, so Unacademy is offering 23% discount on all subscriptions. Enroll on the eve of New Year, and this offer is valid for short period, limited time period only. So make use of this. And Unacademy is conducting mock exams free of cost for all of you. Enroll as soon as possible and take up the exam. The exam conducted on January 8, 15, 22, 29, and they will give you all India rank as well. So you can cross-check and verify where exactly you stand in competition by writing mock exams. So it give you, so first-hand experience of taking competitive exam. Okay. Then so many exams they are conducting in all disciplines. A reasonable price, and that to 10% discount they are giving. Utilize this as well. Okay, this is as usual regular content, everybody shows this. Now let us jump into the subject. So today we are going to talk about frequency analysis of rainfall data. In general, frequency analysis. Normally, this frequency analysis is performed for such events which are rare and random events. The events which regularly occur. no need to conduct, no need to perform any frequency analysis. Events which extreme events which occur very rare, to find out probability of occurring such events, so we perform frequency analysis. Okay. For example, brushing teeth. Brushing teeth is a regular event, so no frequency analysis is required. Okay. But going to restaurant and having feast at restaurant. Every day we don't go to restaurant. Once in a while we go to restaurant. How frequently we go to restaurant, that we can work out. That may vary. It may be individual to individual, it may be different. An individual may go to a restaurant once in a week, or some other individual once in a month, some other individual once in a while, depending upon his pocket, depending upon the money in his pocket, isn't it? So they are an extreme event for normal individual. Every day we don't go to restaurant and have feast every day, isn't it? Once in a while it happens. For such type of events we perform frequency analysis. Exactly same way, when we design any kind of engineering structure, that structure is subjected to random and rare events once in a while. For example, a building experiences massive earthquake during its life period. It may stand for 100 years. In that 100 years, how many times it may experience a earthquake of so and so magnitude. So based on that, what we can work out? Risk associated with that event, whether it can withstand or it can collapse, isn't it? So to work out that risk analysis, I mean safety analysis, we can call it as safety analysis. Safety is nothing but 1 minus risk. Risk is known to you, safety you can find out. Risk depends on probability of its occurrence. Probability of its occurrence depends on frequency. Actually, our interest is finding the risk associated with that event, so that we can work out safety. In any engineering system or any engineering project, we keep two things in our mind. One is safety, the other one is cost. Everybody try to wind up any project with the minimum possible cost and with the maximum safety. Safety also important, cost also important. Suppose you keep too much emphasis, too much focus you pay on safety, you end up with an uneconomical system, isn't it? Too much economy you keep in your mind, you end up with an unsafe system. So system should be adequately safe and reasonably economical. Such type of systems only we appreciate. Generally we appreciate. To work out such type of things, so we need to perform frequency analysis. Not only in civil engineering, in every engineering it is required. Okay? Not only engineering, even everywhere it is required. So towards working out that, we work out this. So normally there are two rare and random events once in a while hydraulic systems experience. One is rainfall, the other one is floods. A multi-purpose dam constructed in a river that is designed for a flood of certain frequency. When you design for a flood of certain frequency, what amount of safety is there with that flood for that system? So what amount of economy we can achieve? Towards working out, we need to perform this frequency analysis. So frequency analysis is performed on random and rare events, random, rare and extreme events. So it is performed on random, rare and extreme events, right? So rainfall and floods. Are two hydrological events which are used in the design of hydraulic structures. hydrologic systems otherwise, such as bridge, okay, dam, culvert, etc. Bridge across a river. For what flood we need to design? Dam across a river. For what flood we need to design? A culvert across a road. For what flood discharge we need to design? So, culvert is nothing but a small underpass which allow water to flow from one side of the road to other side of the road. So that it has to handle the flood discharge, flood only. So every system is designed for flood only. Floods occur due to rain, indirectly linked to rain. Okay? Such as bridges, dams, culverts, etc. Any kind of thing. Okay? So probability of occurrence of these events are found by frequency analysis. That is the reason why we need to perform frequency analysis. Eating breakfast, no frequency is required. Isn't it? Every day we have breakfast. That is a regular event. Right? Such type of events, no frequency analysis. Similarly, so there are some events, hydrological events, which regularly happens. For example, you see evaporation. Every day water evaporates from water bodies. That is a regular phenomenon. So for such type of events, no frequency is required. Okay? But rains, every day, it doesn't rain. Rains occur once in a while. Rains occur once in a while. Therefore, for such type of events, we need to perform frequency analysis. Flood, it doesn't happen every day in the river. Once in a while it happens. So when it happens, how much damage it causes? To work it out well in advance, before it happens, we need to perform frequency analysis. Okay? So, actually, we use these floods and rainfall as design parameters in the design of hydraulic systems. So therefore, if you choose a rainfall of certain magnitude, what amount of risk is there, what amount of safety we can attain. If you choose a flood of so and so magnitude, what amount of risk is there, what amount of safety we can achieve. Towards working out, we force it to work out frequency. We force it to perform frequency analysis. Okay? I am talking about frequency. What is this frequency? This frequency, general term it is, but civil engineers, most of the times we call it as return period. Frequency or return period. We denote it by T. Frequency or return period, sometimes it also known as recurrence interval. All of them are one and same. So it is a time interval between the occurrence of an event of certain magnitude, which is most likely to be equaled or exceeded. Right? Time interval between the occurrence of an event of certain magnitude. Suppose, for example, a student writing the exam. When a student writes the exam, in every exam he writes, he will not stand number one in the class, isn't it? A student stand number one in the class. Once in every 10 exams he write. Some other student stand number one in the class. Once in every 100 exams he take. So that is his frequency. Frequency varies from person to person. Exactly. Here also, for floods and rainfall also, for every rainfall having certain magnitude, it has got certain frequency. Similarly, every flood having some magnitude, it has got a frequency. So that's what we need to work out. So frequency or return period. It is a time interval between the occurrence of an event of certain magnitude which is most likely to be. Most likely to be means what? We are applying probability concept. Most likely to be equaled or exceeded. Equaled or exceeded during its life period. Time interval between the occurrence of an event of certain magnitude which is most likely to be equaled or exceeded is known as frequency or return period or recurrence interval. Understood? Hope it is clear to you now. Any doubt is there? You can type there. Type your doubts there. Okay? How to find it out? So to perform this frequency analysis, we require data. Data is required related to that event. If data is available, you can find out. So if data is given to you, how you can work out? That's also important. So to perform frequency analysis, it requires time series of data. Data with respect to time. Time is important because frequency has a time interval. So monthly rainfall data is given, you can work out frequency in terms of month. Yearly rainfall data is given, you work out frequency in terms of year. Daily rainfall data is given, you work out frequency in terms of days. So time series of data is required. To perform frequency analysis, it requires time series of data. The normally used time series is annual series. Annual series. That means annual flood or annual rainfall only we use into account. Annual series. Okay? So if data is available, how you can work out frequency? So this data we need to arrange in certain order. Then we can work out frequency. Time series of data. Okay? In that data, probability of occurrence of any event we can work out by, we can find by frequency analysis. Okay? Let us see. How to find? There are some empirical equations are available to work out this frequency. So, empirical formulae used to find out frequency are, empirical formulae means what? Formulae are which are not derived, which are proposed by somebody. They have tested, found good, they are acceptable for us. Empirical formulae to find T. T stands for what? What is T? Frequency or time recurrence interval or return period. Understood? Okay? Empirical formula are there. Very popular among all these formula is Weibull's formula, which is equal to T is equal to n plus 1 by m. This formula is very popular. This is known as Weibull's formula. Weibull's formula. And one more formula is T is equal to n by m minus 0.5. This is called Hazen's formula. So sometimes they will mention you which formula to be used to work out T. If nothing is mentioned, then the best among available formula is Weibull's formula. By default we use Weibull's formula. If they are particular about any one formula, then we use that formula. Hazen's formula, work out T by Hazen's formula means then we use Hazen's formula and we work out. But all these formula they don't give T value same. Close values they give. We get close. Not same value but they are close only. Then third formula is very simple formula. T is equal to n by m. This is called California formula. Then what is n? What is n? In all these formula n and m carry same meaning. In all this formula n is equal to number of data, number of annual data used in, suppose 10 data you use, 10 years data use, n is equal to 10. 100 years data use, n is equal to 100. 50 years data is available. Using that data we perform frequency analysis, n is equal to 50. So number of annual data used in analysis. Okay? M is equal to rank assigned for a given data for which you require frequency. Rank assigned for a given data for which frequency is required, for which t is required. That's it. Simple as such. What is there? Very simple and very easy. See now let us see procedure. What procedure is there? How to arrange this? How to find out this? Procedure is arrange the data in descending order of their magnitude. Descending order means what? Highest to lowest. Descending means what? You are climbing down. When you climb down, when you are high point. So high to low is called descendancy. Low to high is called ascendancy. Climbing up is ascending. Climbing down is descending. So procedure. First is arrange data in descending order of their magnitude. Assign rank for each data following the same order. Assign rank for each data in the same order, following the same order. Then find t. That's it. Nothing is there. Find t by using any one of the formula listed above. Nothing is mentioned. Which formula you have to use? Webble's formula. That's it. Shall we go ahead with one numerical? You can understand better. Okay? Let us try one question. Because our GATE is more of numerical oriented. They don't ask 3 questions. So example 1. Let us take first example. The observed annual peak flood of a river in meter cube per second for a period of 9 years are given below. The observed annual peak flood of river in meter cube per second for a period of 9 years are given below. It will give you all the data. So 100, 80, 120, 70, 60, 75, 50, 130 and 40. Find 3 questions are there here. Return period of floods having magnitude 80 meter cube per second. That's first question. Second question is 75 meter cube per second. And third question is 50 meter cube per second. So different magnitudes of flood discharge is given to you. For this flood discharge, what is return period? For this flood discharge, what is return period? That work out. Okay. So what is the procedure? So this data is there. That data is, this is the data. Flood data is given to you. This data you have to arrange in descending order of magnitude. See now, among all this data, which is the highest value? 130. So 130 is kept on the top. So that is given number 1 rank. Next highest value? 120. Next highest value? 100. Next highest value? 80. Next highest value? 75. Next highest value? 70. Next 60, 50, 40. No data is repeated. So no issue. Sometimes the same data repeated couple of times. In such case also, we need to use 3 times it is repeated, 3 times you have to post that data. Understood? So I am arranging the data. So flood data in descending order. Descending order means what? High to low. Which unit system is given flood data? Meter cube per second. So rank, I am writing rank also. So what is the highest value here among all these data? 130, first value. 130. So I'll put tick mark there, so that we don't get confused. Next highest value is 120. Okay, 120 also taken into. Sorry. Next highest 100. Next highest 100 also took, right? Next highest 80. Next 75. 80. 75, 70. So we took all these values. I am just striking off so that we don't leave any data. Then 60, 50, 40. 60, 50, 40. So all data is posted. 60, 50, 40. Now can't assign rank. Highest data is given, number 1 rank. Next 2, 3, 4. In your class also, based on marks they give ranks, no? Exactly same way. 2 people get same marks, they will be given same rank. While assigning the rank for next person, they will skip that rank. Understood? Suppose 100 marks, 2 people got 80, 80. 80 is repeated two more times. Suppose 80 rank is 4 here, 4. So we'll give same rank for all 80s. Whilst giving the rank for 75, what we do? It is repeated 2 times. Therefore, we skip 2 ranks while assigning rank for next magnitude. So we give 4, 5, 6. This will be given 7. Understood? Or otherwise, blindly give ranks. And if same data is there, so 3 different ranks are there. The minimum rank you take and use it. That way you can work out. Okay? So they'll confuse you by giving same data repeatedly couple of times, just to confuse you. So therefore what you need to do? So whenever magnitude is same, give the same rank, while assigning the rank for the next magnitude, next lower magnitude, skip few ranks. Suppose 2 times it is repeated, 2 ranks is skip. 3 times it is repeated, 3 ranks is skip. It's exactly same. Here no such problem. This plain it is 4, 5, 6, 7, 8, 9. What is the question you see now? You have been asked to find out return period for flood 80 meter cube per second. Right? First question, that is. 80 meter cube per second, what is the rank? 4. So therefore, first question solution. So T for, I am finding T. T for flood greater than or equal to 80 meter cube per second. Okay? I am working out return period for flood having magnitude greater than or equal to 80 meter cube per second. So how many data is there? Total data. How many years data it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 years data. Therefore n is equal to 9. Rank for 80 meter cube per second is 4. So nothing mentioned regarding the formula. Which formula you have to use? Bibble's formula. What is Bibble's formula? N plus 1 by m. Therefore 9 plus 1 by 4. 10 by 4 it is 2.5. The unit is years. So that means what? A flood of magnitude 80 or more than 80 meter cube per second occur in that river once in every 2.5 years. Once in every 2.5 years, that river experiences a flood of magnitude 80 or more than 80 meter cube per second. That is the meaning of that. Understood? This is the first question answer. Or second question answer now, you try on your own. Second question answer, you try. What is second question? T for flood greater than or equal to 75 meter cube per second. What is rank for 75 meter cube per second? It is 5. Okay? So therefore, n is equal to same 9, m is equal to 5. Therefore, t is equal to n plus 1 by m. It is 9 plus 1 by 5. It is 2. So flood of magnitude 75 or more than 75 occur in that river once in every 2 years. That is the meaning. Hope it is clear to you. Third question. T for, see now, magnitude decreases, then the time interval also decreasing. That means high magnitude events occur, time interval between occurrence is very, very high. Isn't it? Low intensity, low magnitude events frequently occur. So that's to show you that point. These 3 questions are given to you. 50 meter cube per second. Magnitude is still less, no it is? So T for flood greater than or equal to 50 meter cube per second. Again, n value is equal to 9. Rank for 50 meter cube per second is how much it is? 8. Therefore, T is equal to n plus 1 by m. It is 9 plus 1 by 8. So it is 1.25 years. Flood of magnitude 50 or more than 50 meter cube per second occur once in every 1.25, because it is low magnitude. Similarly, 10 meter cube per second, still it takes less time to happen, isn't it? So, when we design, we always design for highest value. Highest value, time interval is more. So, based on that, we can work out risk and other things, okay? That is the reason to work it out. Hope it is clear to you. Now, actually our interest is not finding return period. Our interest is finding what? Safety, safety, safety. How much safety is there with that system? If I choose a flood of 50 meter cube per second and design a bridge across a river, what amount of safety is there? Safety depends on what? If that flood frequently occurring during that life period, the bridge has got a life period of 50 years. In that 50 years, regularly 50-50 it experiences, more risk is there. Once in a while it happens, less risk is there. So that's how we need to work out. Okay, let us see. So our interest is finding what? Safety. Let us see how we can work out safety. So safety, before we work out safety, let us see. So risk analysis, we perform risk analysis. Risk is known, safety can find out. Okay? Now let us see. Let P be the probability of occurring an event. Probability of occurring an event. And Q be the small p, small q. Probability of not occurring an event. Okay? Okay, I took small n, I took. Okay, capital N also you can take. Number of data. Let me take capital N, okay? Reason I'll tell you. Because small n elsewhere also we use small n, again you'll get confusion. Okay, I took, I replaced that small n by capital N. No problem. It could be any letter. It doesn't make any difference. Because small n is used elsewhere. So I don't want to confuse you. Okay? Clear now? This I took it as capital N. So normally small n we use for life period of a component. So 2 times that if I use, you may be confused. So that's why let me change it to capital N. Hope you are following me. Okay. Now let us see. Probability of occurring an event is P, small p. Probability of not occurring an event is Q. So how to find out this probability of occurring? So this probability of occurring an event is 1 by T. That's it. So simple and so easy. Okay. Probability of not occurring an event is what? 1 minus P. Probability of occurrence, probability of not occurrence is equal to 1. Isn't it? Probability of occurrence plus probability of not occurrence is always equal to 1. So if you know probability of occurrence, can't you work out probability of not occurrence? 1 minus P. P plus Q is equal to 1, therefore Q is equal to 1 minus P. Clear? Now, listen carefully. This something like mathematics. Last year GATE exam, one good question they've asked. Even I struggled to answer that. Because that is purely mathematical. Concept is okay, but mathematical solution even I could not solve that properly. Okay, anyway. P be the probability of occurrence an event and Q be the probability of not occurrence. Probability of occurring an event n times r times in n successive years. Probability of occurring an event, understood? Probability of occurring an event r times in n successive years. Probability of eating dosha 2 times in a week. Eating dosha 2 times, r is equal to 2. In how many days? In a week, 7 days. N is equal to 7, small n that is. Right? Probability of watching a movie, 3 times probability of watching 3 movies in a month, like that. Okay? So probability of occurring an event r times in n successive years. Funny, no concept? Huh? Small n I am using here, that's why I changed it there. R times in n successive years. We use it as P R n. Okay, this P R n how to calculate? Probability of occurring an event r times in n years is equal to, it is NCR into P power r into Q power n minus r. And if you expand and write, it is n factorial by n minus r factorial into r factorial into P power r into Q power n minus r. So this is probability of occurring an event r times in n years. Could be anything. Probability analysis you can perform to any data. Not only for rainfall and flood, everywhere we use this concept. Okay? Now listen carefully. Probability of not occurring an event in n successive years. Come on out, find out. Probability of not occurring an event in n successive years. Not occurring event means what? Occurring 0 times. So if I substitute 0, wherever r is there I substitute 0, then I will get probability of not occurring an event. Understood? So probability of not occurring an event, not occurring, probability of an event not occurring at all, probability of an event not occurring at all. In n successive years. That means what? Probability of occurring 0 times in n years. What is I have given? Here r is equal to 0. Not occurring means what? Occurring 0 times. Okay? So therefore, P 0 n is equal to, actually what is PRN formula? What is PRN formula? PRN is equal to n factorial by n minus r factorial into r factorial P power r into Q power n minus r. This is the concept. So now I am substituting, instead of r, I am replacing r with 0. So probability of not occurring an event at all in n successive years is equal to, it is n factorial by n minus 0 factorial into 0 factorial P power 0 into Q power n minus 0. So this whole thing become 1. Then finally left with what? Q power n. N factorial by n factorial into 0 factorial. Right? This 1. So Q power n. So probability of an event not occurring at all in successive years is equal to Q power n. Okay? Now, be careful. The actual concept is coming now. Probability of occurring an event at least once in n successive years. At least once means what? Occurring one or more number of times in n successive years. So probability of occurring one or more number of times in n successive years is nothing but a risk. More number of times it occur, more risk is there. Risk is more, isn't it? Earthquake occur more number of times during the life period of a building, the risk for that building is very, very high, isn't it? So probability of occurring an event at least once, whenever you heard the term at least once, what does it indicate? Risk associated with that. That is occurring one or more number of times. Understood? So probability of occurring an event at least once. At least once in n successive years. At least once means what? Occurring one or more number of times. So that means what? That means what? That means what? 1 minus probability of not occurring an event. Right? This is nothing but risk, which is equal to, this only we call it as risk, which is equal to 1 minus probability of occurring one or more number of times means what? 1 minus probability of not occurring an event. Not occurring an event probability is 0.2. Probability of occurring an event at least once in n successive years means what? 1 minus 0.2, isn't it? So risk is equal to, it is 1 minus probability of not occurring an event. That is 1 minus q power n. Understood? So whenever we come across with risk R, we denote it by R is equal to, it is 1 minus q power n. Understood? This is where confusion. 1 minus q power n will give what? Risk. Okay? Once you know risk, you can find out safety. Safety associated with this system is equal to 1 minus risk. Safety plus risk is equal to again 1. So if you know risk, safety you can find out. So 1 minus R. Or sometimes in percentages also we can work out. Or otherwise, if you work out in percentages, 100 minus percentage risk. Risk also work out in percentage. Safety also can get in percentage. Safety in percentage is equal to 100 minus percentage risk. Or in fraction also can express. That means which is nothing but probability of occurrence only. Probability of occurrence you can express either in terms of fraction or you can express in terms of percentages. So percentage safety is equal to 1 minus percentage risk. That's it. Understood? Our job is finding risk only. Very popular question in GATE exam this is. 100% every year you will find one question. Nothing is there. 2 marks question they will ask. See now? So simple concept. So, because we apply this to hydrologic event, we call it as hydrologic risk. Hydrologic risk or simply risk, both of them same only, is equal to, it is 1 minus q power n. That's it. They are n methods. Hope it is clear to you. Take a deep breath. Go through once again this concept. Only formula you have to remember ultimately. If you digest the information, if this concept goes into your brain, mind permanently, you understand it concept, then finally you have to remember formula. But blindly if you remember formula without concept, it is of no use. You don't know what is Q, what is N, what is R, what is this risk. This kind of confusion would be there in your mind. Just mugging up formula will not give you success in competitive exam. Concept, learn the concept, right? Understand the concept, and ultimately formula you can remember or you can mug up, then reproduce in the exam. Comfortably you can recollect back what is that, Q, what is R, what is this, what is that, isn't it? So generally, if you know risk, we can also find out safety. That's what I wrote here. Okay, safety or assurance, whatever it may be. Indirectly also they will ask sometimes they will give. So exam point of view, what I mean to say is, so whenever they give a question, two ways they ask. They will give you for a given t, right? What is risk? For a given risk, what is t? That's all. T is given to you, what is expected from you? R. Whenever R is given to you, what is expected from you? T. There it matters. So simple, so easy. Let us try to solve problems. Okay? Numericals. Example 2. Hope it is clear to you. No comments. Why no one is following? Wow. This is online education. Pathetic. Okay, anyway, that is where I did. I'll take one example and let me explain you. A rainfall of certain intensity expected to occur once in 20 years. A rainfall of certain high intensity is expected to occur once in every 20 years. Okay, what is the probability that it may occur in the next 12 years? Come on, work out, guys. So what options are given? Options are given here. It is whole gate question only. 65.88% in percentage is given. Okay, before we solve this question, okay, B 34.12%, C, that's what I am saying. Probability of occurrence you can work out in fraction, probability of occurrence you can work out in percentage. Already explained you, okay, no need. 54%, then D 46%. Come on, let us try this one. Let me see how many of you work out and post your answer there in comment box. None of you watching first of all. Come on, what is given there? Expected to occur once in 20 years. What is that once in 20 years? T. T is given as 20 years. Solution to this question, okay? T is given as 20 years. That is return period. What is the probability that it may occur in the next 12 years? What is that? He is asking probability of occurring at least once in next 12 years. Probability that it may occur in next 12 years means what? Our interest is finding risk only, blindly. That it may occur in the next 12 years. That means what? Probability of occurring at least once in the next 12 years. So this terminology has to sink into your brain, mind. At least once in next 12 years. What is that? R only. So what is n here? Small n? 12. Small n is equal to 12 years. Right? Then he is asking what? Risk. Come on, work out. Risk is equal to what is the formula? 1 minus q power n. So what you need to work out? Q. Q, how you can find out P? How you can find out P? T. T is required. So T is given. So P is equal to 1 by T, 1 by 20, 0.05, 1 by 20, 0.05 only, no? 1 by 2 means 0.5, 1 by 20 means 0.05. Then Q is equal to 1 minus P, 1 minus 0.05, so 0.95. So what is risk? R is equal to 1 minus Q power n. So 1 minus 0.95 to the power 12. Come on, let us work out. Calculators you can use because in the exam calculator is allowed. Virtual calculator is provided to you. 1 minus 0.95 to the power 12. It is 0.4596. I got 0.4596 because answer is given in percentages. I'll express in percentage. 45.96%. 45.96% exact value this is. Let us see the options given there. 45.96 option is not there. What is the nearest option? It is rounded to 46. 45.96 is rounded to how much? 46%. So, tick mark what? Nearest value answer. 46%. Got it now? Yes. Clear now? Next, let us see next question. Example 3. A bridge has an expected life of 50 years and is designed for a flood magnitude of return period 100 years. What is the risk associated with the hydrological design? So straight question, this is nothing is there. A bridge has an expected life of 50 years and is designed for a flood magnitude of return period 100 years. What is the risk associated with this hydrologic design? Come on now, let us work out this question. Expected life of 50 years. That means what? N is equal to 50 years. It is designed for a flood having a magnitude, having a return period 100 years. So T is equal to 100 years. Okay? Then he is asking, what is the hydrologic risk? Or simply risk, otherwise. So from this what you need to work out? To work out risk, what is required? Q is required. How you can find out Q? With the help of P. So therefore, first we need to work out P. So P is equal to 1 by T is 1 by 100, 0.01. Then Q is equal to 1 minus P, 1 minus 0.01 is 0.99. Then hydrologic risk is equal to so 1 minus Q is 0.99 to the power n. 50 years, expected life of 50 years. In 50 years, how much amount of risk is there? So 0.99 to the power 50 minus 1 is 0.394. Of course, for this also options are given. The options given are, of course I don't have space here. He has given in percentages. A 39.5%, B 60.5%, C 30.55%, D 62.5%. So we got how much our answer is 39.49. So it is 39.49%. It is rounded to 39.5%. That is how you need to work out the question. So option 39.5. Option A is right answer. Understood? So your concept is right. No way you can go wrong. You never ever go wrong. Okay? But concept is important. Similarly, let us work out one more question. Okay? Good question this is. Risk is given, you are expected to find out return period. So example 4. The return period that a designer must use in the estimation of a flood for a hydraulic structure if he is willing to accept 20% risk that a flood of that or higher magnitude will occur. In the next 10 years is, the options given are 95 years, 75 years, 45 years, and D is 25 years. Come on, work out. You should try. Every question if I solve, then there is no use. So solution should come from your side. Come on, what is given there? Risk is given. He is willing to accept a risk of 20%. So risk R is given as 20%, nothing but 0.2. The next 10 years. So n value is given as, small n is given as 10 years. So I have been asked to find out what is that return period that he has to choose. So R is equal to 1 minus q power n. So R is given as 0.2. 1 minus q to the power 10. So from this, work out q value. So q is equal to 1 minus 0.2 whole power 1 by 10. So it is 0.9779. Okay? Then P is equal to 1 minus Q. 1 minus 0.9779. So it is 0.0221. Therefore, T is equal to 1 by P. One by 0.0221. So it is 45.24. What is the nearest available answer? Exactly, fraction values are given. 45 is the nearest available answer. So he has to take a risk of a return period of 45 years. So it is rounded to 45. Given answer is 45 years. But we had little more, 45.24 exact value. So that is how we had to work out. Let us take one ESE question. This question you can solve without calculator. How to work out the same problem without calculator? Let us see that also. So let us take next question. Example 5. This is ESE 2012. The hydrologic risk of a 100-year flood occurring during two-year service life of a project. Okay, options given are 9.8%, 9.9%, 19.9%, 1.99%. Come on, simple stat question it is. But without calculator. That's only the point you need to notice. So what is given? 100-year flood. That means T is given as 100 years. Return period is 100 years. And you have been asked to find out hydrologic risk or simply risk. What is service life? 2 years. Come on, if T is known, can't you work out P? P is equal to 1 by T. So it is 1 by 100. 0.01. If P is known, can't you work out Q? What is Q? Q is equal to 1 minus P. So 1 minus 0.01 is 0.99. Okay, then hydrologic risk is equal to one minus q power n. So 1 minus 0.99 to the power 2. So 0.99 square, that you can find out without calculator also. Is 0.98. 0.99 square is 0.98. 1 minus 0.98 is 0.02. 0.0199. This is percentage you work out into 100. You multiply with 100 is 1.99%. That is the answer approximately. Or otherwise 0.09998, it is almost 0.02, 20%, close to 20%. So anywhere 20% or 2%, 2% is not given, 1.99 is given, you can tick mark 1.99. That was the answer for that question. Easy only, no? You can manage. Hope you can manage. Next, few more good questions let us try to work out. Yeah, one more question. A very good question this is. Example 6. A flood of, I got collection of questions, from there I am taking this, 4000 meter cube per second in a certain river has a return period of 40 years. First question is, what is its probability of exceedance? And second question is, what is the probability that a flood of 4000 meter cube per second or greater magnitude may occur in next 20 years. Third question. Come on, this single question is solved, you will be very clear about the concept. What is the probability of occurring a flood of magnitude less than 4000 meter cube per second? Come on, try this question. I'll give you 2 minutes time, try. And type your answer there in comment box. Completed? Okay, first part is very simple. Probability of exceedance means when you express probability of occurrence in fraction, it's called probability of exceedance. I'll write here, okay? If probability of occurrence expressed in terms of fraction value, then it is called exceedance probability. If probability of occurrence is expressed in terms of percentage, then it is called chance percentage. So whenever they ask you chance percentage, which is nothing but probability of occurrence only, you have to express in percentage. Exceedance probability means you have to express in fraction. Okay? That means finally what I mean to say is probability of occurrence can be expressed either in fraction value or in terms of percentage. But in this question what you have been asked to find out exceedance probability, probability of exceedance. That means you have to express no option, you have to express in fraction only. That's the meaning. So, he has given flood magnitude greater than or equal to 4000 meter cube per second, right? Which has got a return period of 40 years. So, for this t is equal to 40 years. First question is what? Probability of occurrence only. Probability of occurrence. So p is equal to 1 by t. So it is 1 by 40. So 0.025. That was the answer for first question. Express in fraction. That's all. It's become probability of exceedance. Exceedance probability is equal to 0.025. Probability of exceedance. He has asked probability of exceedance, right? Okay, we'll use his language only. That's all. That was answer for first question. Second question, what is that? What have been asked to find out? What is the probability that flood 4000 meter cube per second greater magnitude may occur in next 20 years? That means occurring at least once in next 20 years. Flood greater than or equal to 4000 meter cube per second may occur in the next 20 years. Indirectly asking risk in the next 20 years. Occurring at least once in next 20 years. Nothing but risk. So indirectly asking risk. So n is equal to 20 years. Can't you work out risk? So Q is equal to 1 minus P. So 1 minus 0.025. Already P we got. 0.025 is equal to 0.975. Therefore risk R is equal to 1 minus Q power N. 1 minus 0.975 to the power 20. Come on, work out. So 0.397 it is. .3973. That is the answer for second question. And third question. Third question is little tricky. Probability of occurring flood less than 4,000 meter cube per second. But we don't have concept for less than. Equaling or exceedance only this concept. So magnitude less than given magnitude we don't have any concept. But indirectly is asking. So probability of occurring flood less than 4,000 meter cube per second is equal to, indirectly this is nothing but probability of not occurring flood more than 4,000 meter cube per second. Probability of not occurring flood greater than or equal to 4,000 meter cube per second, which is nothing but probability of not occurring means Q only. Is indirectly asking Q. What is Q? Already we got. Q is equal to 0.975. That's it. There end matters. So already we got Q here. So same Q. That is the answer for third question. Understood now? So this is how we can work out. Hope this concept is clear to you. Okay? Then little more I need to add here. One more small concept is there. Stationary method. This is some kind of procedure we use to find out high frequency events. When I've been asked to find out, normally when we design this very important hydrologic systems such as multi-purpose dams, etc., we design for floods having very high return periods, 1000 years, 500 years, 300 years, something like that. but unfortunately we don't have that much data available with us, isn't it? So data available is very few data available, because we started recording this rainfall data, flood data just before independence time onwards. That means that we have got only less than 100 years data, but we are expected to design the system having a return period 1000 years, having a return period 500 years. Then how it is possible? Because return period 500 years, 1000 years means what? So T is inversely proportional to number of data that we use, or straight away proportional to number of data. Inversely proportional to rank, isn't it? Straight away proportional number of data. So 1000 data is available, 1000 years return period we can work out. Right, but unfortunately we don't have that much data. Therefore, to forecast such type of floods having very high return periods, rainfall having very high return period, artificially we try to generate data. That method of artificially generating so much data to work out high frequency events such as rains and floods, to design very important hydraulic systems. That method of generating that data is called stationary method. So method of generating suppose there are some 10 rain gauge stations are there in a catchment, and each rain gauge station has got 100 years data. So 10 rain gauge stations data, if you combine into one single data, right, then you will get 100 into 10. 1000 data is available with me. With that 1000 data I can work out high frequency events. That is the meaning of this. Understood? So method of generating long length of record at an imaginary station by combining all of the records available at all over the places. The procedure is called stationary method. This technique is used to find out floods and rains having very high return periods. So very small concept too. This is method of generating a long length of record. At an imaginary station by combining all of the data available at all of the stations. Is known as stationary method. Just 1 minute. చెప్పు, నేను క్లాస్లో ఉన్నా. So method of generating long length of record at an imaginary station by combining all of the records available at all of the stations into one single record. The technique is called stationary method. Okay, just remember, one time this question has been asked in GATE exam. Next, one more small concept is probable maximum precipitation. It is PMP. So it is extreme precipitation which is physically possible to occur. It is not imaginary thing, which is very much physically possible to occur, is known as probable maximum precipitation. Extreme precipitation which is physically possible to occur in a catchment is known as extreme rainfall, that is, and no rainfall occur better than this value, probable maximum precipitation. So this we can work out by statistical procedure. So this probable maximum precipitation is equal to, it is P bar plus K suffix T into sigma. So using this expression you can find out probable maximum precipitation. P bar is known as, right, average rainfall data, average precipitation data, average of the average value of the precipitation data. Precipitation data is available with us. So it is average value. And sigma is known as standard deviation of the precipitation data. And this KT is known as frequency factor. This KT is known as frequency factor. Okay? This KT value we work out by using equation. It is YT minus YN bar by SN bar. Okay, I'll take capital N because this Y bar and S bar depends on N value. N is number of data used in the analysis. Okay. So if N is not given, N is equal to, this YT is called understood. This YT is called Y capital T, you can write. This YT we work out by using equation minus ln into 1 minus P. That means Gumbel has defined as probability of occurring an extreme event is known as probability of occurring an extreme event is defined by Gumbel as 1 minus e power minus YT. This is the probability of occurring extreme event. So if we simplify this, we will get this. This is Gumbel's extreme function value. Gumbel has defined as probability of occurring an extreme event is equal to 1 minus e power minus YT. So if you simplify that, you will get this. So YT is called reduced variate, that is. Okay. The YN bar is called mean of reduced variate. This is YT is reduced variate. And SN bar is standard deviation of reduced variate. Standard deviation of reduced variate. So this YN bar and SN bar we can read from Gumbel's probability tables, or read from Gumbel's probability tables, and their value depends on n, sample size n. Depends on sample size n. Okay, against n, 50 Hz data, YN bar is different, SN bar is different. 30 Hz data, YN bar is different, SN bar is different. So this we can read from Gumbel's probability tables. Next, suppose if n value is not given, then it is assumed as infinite sample size. If n is not given, if sample size n is not given, then it is assumed as infinite sample size. So for infinite sample size, YN bar and SN bars values are taken as, so if n tends to infinity, then this YN bar is taken as 0.5778 and SN bar is taken as 1.2825. Okay? Then for infinite sample size, what is YT value? What is YT value? YT value is, no. For infinite sample size, what is KT value? KT. Frequency factor KT for infinite sample size is, it is YT minus 0.5778 by 1.2825. Most of the times we use this. So when n tends to infinity. This is true only for this. Sample size is infinity, then you can use this. Okay? That's all. So finally formula substitution. Probable maximum precipitation P bar plus KT into sigma. So let us try one question related to this so that you become familiar with this concept as well. So we can't take risk in exam. Any kind of question they may ask. So this is the last variety of problem in frequency analysis. So let us try one question. This question is asked in ESE exam. Example 7. We call it as frequency analysis topic only. It is the regression analysis of a 30-year flood data. So sample size is 30 years. Capital N is equal to 30 years. At a point on a river, yielded sample mean. Flood data, for flood he has applied. For flood it is taken as X bar, 1200 meter cube per second. And standard deviation . 650 meter cube per second. Of course, he has given S bar, Sx, okay, but we took it as sigma. Probable maximum precipitation, probable maximum flood means it is x bar plus kt into sigma. So he has given Sx. Whatever symbols he use, it doesn't make any difference. For what discharge would you design the structure at this point? To provide 95% assurance. That structure would not fail in the next 50 years. The value of mean and standard deviation of the reduced variate for n is equal to 30 or 0.53, 622 and 1.11238 respectively. These values are picked from Gumbel's probability distribution model respectively. Okay, let us try this question. So what have been asked to find out? What is that flood magnitude we need to choose so that we can provide 95% safety in the next 50 years. So probable maximum precipitation equation is, it is P bar plus KT into sigma. If it is flood, we write it like this. Probable maximum flood is equal to, it is X bar plus, same concept to flood data we use, KT into sigma. So in this equation what is given? X bar is given, sigma is given. In this question, X bar is given as 1200 meter cube per second. Sx is nothing but sigma, standard deviation. This is given as 650 meter cube per second. Then for sample size n is equal to 30. So yn bar is given, Sn bar is given. Yn bar is given as 0.53622. Sn bar is given as 1.11238. This is also given to you. And what he is saying, what is that flood discharge? He has to choose. That is probable maximum flood. To provide 95% assurance that structure would not fail in the next 50 years. So, assurance is given as, assurance is nothing but safety. Percentage safety is given as 95%. In the next 50 years, small n is equal to 50 years. Okay? So what is required to work out this probable maximum flood? So it is x bar plus, it is called probable maximum flood, we call it as xt, having return period so and so. We denote it by xt is equal to x bar plus kt into sigma. So x bar is given, sigma is given, kt value at workout. To work out kt value, so we require yt value. To work out yt value, what is required? Probability of occurrence. So probability of occurrence is not given, but safety is given. From safety you can find out risk. Easy question only, formula substitution only, but indirectly given. So percentage safety is given as 95%. Therefore percentage risk is 100 minus percentage safety. So 100 minus 95, 5%. So risk is 5%. So R is equal to 5%. 5% means 5 by 100. Fraction value means 5 by 100 means what? How much it is? 5 by 100. So 0.05. If R is equal to 0.05, N value is given as the next 50 years. N is equal to 50 years. Can't work out probability of occurrence. 1 minus q power n. So this is 0.05 is equal to 1 minus q power 50. From this you can find out q. Q is known to you, p you can find out. So 1 minus 0.05. 1 by 50. So it is 0.9989. Therefore P is equal to 1 minus Q, 1 minus 0.9989. Or you can use, instead of 1 minus P is equal to Q also you can use. 1 minus P is nothing but Q. So you can work out what is that term? YT. YT is equal to minus ln into 1 minus P. Okay? So minus ln into 1 minus P is Q only. Minus ln into 0.9989. So ln answer into minus 1. Again once more time ln. Ln answer into minus 1. So its value is 6.8822. Its value is 6.88. Y2 we got. That's all. Then you can work out KT. So KT is equal to, it is YT minus YN bar by SN bar. So YT we got 6.88221 because he has given 5-digit value YN bar SN bar 0.53622 minus 0.53622 by 1.1111238. That's all. KT value workout finish. Problem is over. Minus 0.53622 by 1.11238. So it is 5.7048. That's all. Therefore, probable maximum flood for which that building has to be designed. Building or bridge? What is that? That building has to be building a structure. That structure has to be designed. X bar plus KT into sigma. X bar also given. X bar is given in the question as 1200 plus 5.7048 into sigma is 650. So this into 650 plus 1200. So if you design that structure for flood of magnitude 4908.1742 meter cube per second, then you have 95% safety in the next 50 years. That is the meaning of this question. Wonderful question. No? Nothing is there, but only link it is. How to make use of that probability concept, risk concept, how to link that to probable maximum flood or probable maximum precipitation. So this is how we can work out numericals related to this frequency analysis numericals. I hope I covered all varieties of problems. Last year GATE exam, one typical question they asked. So I'll give that question to you if possible. Even I don't know how to arrive mathematical solution. Even I too don't know. Example 8. This year, this is GATE 2022. Very good question this is, but solution, mathematical treatment is not known to me, but concept is same wherever we apply. So with the mathematical faculty, we got that information. Let me check that question. It is there with me. Nice question that is. Only one question is asked, but it is easy question only, but only mathematical treatment is difficult. Finding mathematical solution for that is little bit complex. Yeah, last year paper that is there with me in my WhatsApp. I think it's one more question. Yeah. A flood control structure. You try, if you get well and good, I'll give you idea. Having an expected life of 10 years is designed by considering a flood of return period T. T years. When T is equal to N and N tends to infinity, life tends to infinity, N tends to infinity, T is equal to N. The structure's hydrologic risk of failure in percentage is dash. This is the question. So what is given here? N is known, T is known, and he mentioned that T is equal to N and N is equal to infinity. Okay? Then what is the hydrologic risk he is asking. So what is risk formula? Truly speaking, R is equal to 1 minus Q power N, you write. So risk is equal to 1 minus Q power N. Right? Q is equal to what? 1 minus P. Q is equal to 1 minus P whole power N. What is P? 1 by T whole power N. So what he has given? N tends to infinity. So 1 minus 1 by T whole power infinity. N tends to infinity, T is equal to N. Again he is saying that T is equal to N. So if T is equal to N and N tends to infinity, and if we simplify this by trial and somehow we have to work out, if some mathematical function is there, when N tends to infinity, 1 by this 1 by limit N tends to infinity, right? 1 minus 1 by infinity is equal to some mathematical value is there. So from 0.3 is 0.36 or something like that. Okay? Or highest value you can take, let us assume infinite value means 1000 years you take, for example. Let us infinity is equal to 1000 years, for example. If you take n tends to infinity, n value is taken as 1000 years. If you take 1000 years, so 1 by 1000 is nothing but, so it is 0.001. 1 minus 0.001 is 0.9999 something to the power infinity again 1000. So 0.999 to the power 1000, approximately I am saying. Trial and error it is. .999 to the power 1000 is, it's almost 0.3676. So if we take 0.361 minus 0.3676, approximately it is 63.63% you are getting, 63.63. Approximately, I took 1000 years. 1000 years data itself is it is taken as infinity only. Okay, because IMT started just before independence. We have got only 75 years data or max 100 years data, not more than that. Okay, so 1000 years is almost like infinity only for us. So if I take that as that concept, that logic if I apply and if I work out, then 1 by 1000 is equal to 1 by T is equal to 1 by 1000, which is taken as 0.00, 0.1, 0.01, 0.001. Okay, then so 1 minus 1 by T is equal to, it is 0.9999. 0.999 to the power 1000 is nothing but 0.366. So 0.999 to the power 1000 is equal to 0.3676. So 1 minus 0.3676 is So how much it is? Approximate solution I am giving, not exact solution. 0.6324 it is. So roughly 63% it is. So you can round it to 64% or 63%. That's how you can work out. So exact mathematical faculty may know this solution to this equation. Okay, 64% risk is there. So we can work out like this. This is a frequency analysis. Okay, I tried my level best to infuse this concept into your minds. Okay, anyway, so before I conclude, Sun Academy is offering flat 23% discount on the eve of New Year for limited period. This offer may soon close, so make use of this offer. Enroll as soon as possible. Enroll, okay? Hurry up. Offer is going to close very soon. Then they are conducting All India level mock exam. You can enroll it for free of cost. Use the code GATE Civil. Okay, free of cost you can enroll for that program. Then they are conducting so many number of tests in all branches at thrown away price, and that too they are giving 10% discount. Use code GATE Civil. Thank you for attending the class. Okay, tomorrow I am planning to take 2 sessions and each of 1.5 hour duration. Possibly morning I will take from 11:30 to 1 session. Okay, then again 4:30 to 6 I'll take one more session. Tomorrow, this is tomorrow. Tomorrow I am planning to take 2 sessions, each of 1.5 hour duration. First session I will take in the morning, 11:30 to 1. Second session I will take in the evening, 1:30 to 4:30 to 6. 11:30 to 1 p.m. morning session. They will announce you, okay? And again 4:30 to 6. So that will not get bored. It's evening session. So I'm planning to take like this. So tomorrow I'll start abstractions of precipitation. That is evaporation, transpiration, and as well as evapotranspiration, infiltration, etc., etc., etc. In sequence we work out. Okay then. Thank you. Good night all of you. We'll meet again tomorrow. Same place, but not same time, different time. So do note the timings. And we'll meet again tomorrow in the same platform. Okay then, bye. Good night.